Hi everyone. Now we are going to present about practical work 3 in semiconductor devices. First of all, I'm here to introduce my team members. First, I'm Mirdini Anaprampuan Manimaran, ID number 10DTK24F1024. And then Jennifer N. Anaprampuan David Marshall, ID number 10DTK24F1055. And then Reagan Abraham Analalaki Saravanan, ID number 10DTK23F1043.
Nama saya ialah Regan Abraham, anak lelaki Saravanan. Nombor menteri saya ialah 10 DTK 23 F 1043. PNP and NPN are two types of bipolar junction transistors which are used for switching and application electronic circuit. They are made of 3 semiconductor layers and a 3-terminal emitter base collector. NPN transistor such as a layer P-type semiconductor is sandwiched between two N-type semiconductor. Current flow from the collector to the emitter. A current at the base allow larger current to the flow from the collector to emitter. Operation. The base must be positive relative to the emitter to turn it on. The collector is more positive base. The arrow on the emitter point outward, indicating the direction of conventional current flow. PNP transistor such a layer N-type semiconductor is sandwiched between two P-type semiconductors. Current flows from the emitter to the collector. A small current at the base flowing out of the base controls a larger current from the emitter to the collector. Operation. The base must be negative relative to the emitter to turn it on. The collector is more negative than the base. The arrow on the emitter point inward, indicating the direction of the conventional current flow. Thank you.
Hi all, my name is Jennifer N, daughter of David Marshall. My matric number is 10DTK24F1055. So now I would like to explain about the experiment that we have done. Firstly, I would like to explain about the objective of the experiment. Firstly, the objective of the experiment is to identify the type of transistor, which is NPN or PNP, Secondly, to determine which terminal is base, emitter and collector of the transistor. And thirdly, to measure the junction of characteristics using multimeter. So next I would like to explain about the procedure of experiment. First, we must measure with multimeter. The experiment involves connecting the red and black leads of the multimeter to different transistor terminals, which is 1, 2, 3. The meter reading show either a finite resistant value or infinity resistant value. Secondly, we have to analyze our results. If the transistor conducts when the red lead is on the base and the black lead is on the collector or emitter, it's an NPN transistor. If the transistor conducts when the black lead is on the base and the red lead is on the collector or emitter, it's a PNP transistor. The state table helps determine which terminal acts as a base, emitter and collector based on the conduction patterns. Furthermore, I would like to explain about the results interpretation. So as we all know, Q1 is S9013 and Q2 is S9012. Based on our results, we identify Q1 as an NPN transistor because conduction occurs when the red lead is on a base, and Q2 identified as a PNP transistor because conduction occurs when the black lead is on the base. For both transistor, we identify Q1 base at terminal 2 and also terminal with lower resistance reading when forward bias is the emitter. Terminal with higher resistance reading is the collector. In conclusion, Q1 is confirmed as a NPN transistor and Q2 as a PNP transistor based on how they respond to the multimeter's polarity. Base, emitter and collector are identified based on the voltage across junctions. That's all from me. Thank you so much.
Now this is the video and pictures during the lab work. Finally, I'm here to talk about the results. The experiment aimed to identify the type of bipolar junction transistor and their terminals, base, emitter and collector using a multimeter. The result in table 2.0 reflect the conduction behavior of the transistor when different terminals were tested with the red and black leads of the multimeter. First thing, key findings. Q1. Identify an NPN transistor. In an NPN transistor, conductions occurs when the base is positive relative to the emitter. From the table, Q1 shows a reading when the red lead positive is on terminal 2 and the black lead negative in terminal 1 and 3. That confirms that terminal 2 is the base, terminal 1 is the emitter and terminal 3 is the collector. After that, Q2. Identify as an PNP transistor. In an PNP transistor, conduction occurs when the base is negative relative to the emitter. For Q2, conduction happens when the black lead negative is on terminal 2 and the red lead positive in terminals 1 and 3. That confirms the terminal 2 is the base, terminal 1 is the emitter and terminal 3 is the collector. And the results prove transistor type and terminals. Base identification for both Q and the results prove transistor type and terminals. Base identification for both Q1 and Q2. Conduction occurred when the multimeter was connected to the correct polarity for NPN and PNP transistor, proving that terminal 2 is the base in both cases. Emitter versus collector identification. Lower resistor when forward bias emitter. Higher resistors when forward bias based on collector. The conduction behavior is Q1 behaves like an NPN transistor because it conducts when the base is positive relative to the emitter. Q2 behaves like an PNP transistor because it conducts when the base is negative relative to the emitter. Finally, conclusion is Q1 is an NPN transistor and Q2 is an PNP transistor based on their conduction behavior. The terminals were accurately identified using the voltage drop across the junctions. The experiment confirms that working principle of BJTs and how they respond in input signals. Thank you everyone.